So in the next sections, we're going to be looking at both exponential and logarithmic functions. So the first thing we're going to look at is just an introduction to exponential functions. So a function in the basic form, f of x equals b to the x power, b is the base, or we can write it as y equals b to the x, because remember when we learned about function notation, f of x and y are interchangeable. And then we have b is a real number. It's the base. It has to be positive, but not equal to 1. So I can't have any negative bases, and I can't have it equal to 1. There's lots of different variations. We're just going to look at the basic form for this course. So the first thing I want to talk about is why is it important to have restrictions on what b can be? Well, what if it could equal 1? So I'd have y equals 1 to the x. Well, 1 to any power is always just going to be 1. So 1 to the negative 2 power is 1. 1 to the negative 1 power is 1. 1 to the 0 power is 1. 1 to the first power is 1. 1 squared is 1. So it wouldn't actually be exponential. It would just be a straight line. So that's not exponential. The other restriction is it has to be positive. So what happens if I had a negative value? So let's say I had y equals negative 2 to the x. Well, when I go, I'm just going to pick a few values again. I have negative 2. Negative 2 to the negative 2 power. Well, that negative flips it and then squares it, so I get 1/4. Negative 2 to the negative 1 power would be a negative 1/2. Negative 2 to the 0 power is 1. Negative 2 to the first power is negative 2. And negative 2 squared gives me a positive 4. So I started off at negative 2. Say that's 1. Negative 1. So at negative 2, I'm at positive 1/4. At negative 1, I'm at negative 1/2. At 0, I'm at 1. At 1, I'm down here to negative 2. Oops. At 1, I'm down here to negative 2. And at 2, I'm up at 4. So what happens is instead of having smooth curves, we wind up getting these dots all over the place. And we don't want to look at that, right? It's really hard to do anything with it. So that's the reason why we have those restrictions on the bases. So the domain, the x values, well, I can take a real positive number to any power I want. So the domain is going to be all real numbers. Well, how about the range? I'm taking a positive base and I'm taking it to a power. So there's no way I could get anything negative. So this is an example of what an exponential might look like. So my range, oops, didn't mean to put the equal sign there, is greater than 0. Not greater than or equal to. It has to be greater than 0 because, again, I'm taking a positive number and taking it to a power, so it can never actually equal 0. So in your workbook, I have a few examples typed up for you. We have 2 to the x, and again, we're just evaluating at negative 2, negative 1, 0, 1, and 2, and then plotting those points. So that's what y equals 2 to the x looks like. And you see the domain, it's widening, right? It's all real numbers. The range, it gets really, really close to 0, but it never can actually hit 0. So the range is greater than 0. And then I have y, f of x is 1/2 to the x power. Again, evaluating at these points from negative 2 to 2 at the integer values and plotting them. And again, domain, all real numbers, range is greater than 0. So we're going to pick some values and plot them. it's always nice to use numbers that are close to the origin because we don't want our graphs to be huge. So negative 2, I get 4 to the negative 2 power, which is 1 over 16. Negative 1 is 4 to the negative 1 power, which is 1 over 4. 4 to the 0 power is going to equal 1. 4 to the first is 4. And 4 squared is equal to 16. So I just went up by 4s to make it a little bit easier. So negative 2 is 1 over 16. So it's already really, really close to that y-axis. At negative 1, it's 1/4. So it doesn't come up much. At 0, it's 1. At 1, we got 4. And at 2, we have 16. So just so we can see a little bit better. So we have that exponential growth. Here I have y equals 3 to the negative x. Pick my standby. So we get 3 to the negative of negative 2, which is going to give me a positive 2. So that gives me 9. And then 3 to the negative of negative 1, which will be a positive 1. So I get 3. And then 3 to the 0 is 1. And then 3 to the negative of 1, which is 3 to negative 1 is 1/3. And 3 to the negative 2 is 1/9. So negative 2, 1/9. Oops. Negative 2, 9. I'm looking down here instead of up here. Negative 1, 3. 0, 1. 1 is at 1/3. And 2 is at 1/9. So again, domain is all real numbers, and the range is greater than or equal to 0. So determine if these are exponential. Well, the base is positive and not 1, so y equals 1/4 to the x. That is exponential. Y equals 2 to the x. Yes, the base is 2. Y equals 1 to the x. No, because it can't be 1. 5 to the x. Yes. 0 to the x. What do you think? That's going to be no, because remember, it has to be positive. So it has to be greater than 0, not equal to 1. 2/3 to the x is a yes. Negative 3 to the x, and it's in parentheses. So that base is negative 3. So that's going to be a no. 100 to the x. That's a yes. And then there's a couple you can plot from 5 points and then graph it. So I'll let you do that.